Good afternoon. Welcome to Scala.js and why I like it. My name is Stibbe. I work for Quinter as a Java developer by day, and at night I develop Scala in my free time and other things if I have time, because I'm also a father since a year, and that's been eating a lot of my time since. Today we're going to discuss a few things about why I like Scala.js. And I'll start with my dislikings of JavaScript, how I ended up at Scala.js, a little insight in Scala and why I chose that, and from there Scala.js, a little insight, some tooling, and if there's time, some live coding. Oh, okay. Most of you, I think, well, first let me gauge the room a bit. So, how many of you know Scala? That's quite a bit, okay. How many of you have worked with Angular 1.5, for example? Okay, quite some. Okay, that's nice. So, you probably know this picture, right? The documentation of JavaScript and the good part. So, basically, JavaScript was originally created in 10 days, literally. And it has some side effects if you create a language in such a short time, even after 20-some years. 20 years, I think, now. Yeah, and several revisions later, it still has some drawbacks. For example, if you create a typo within JavaScript, it has consequences, unforeseen though. If you have a variable, for example, here, we have a variable called bar. We assign it value 3. Later on, we want to reassign it the value 20. However, I made a typo, and since then, there will be a global variable called buzz. And it will not show up immediately. It will create some mistake somewhere, but not in the place it should be. Then there's scoping. If I, in an if statement, define a variable, bar, it will be available outside the if statement as well. Some may like it, I don't. Function arguments. For example, we have a method with 2 arguments, 1 and 2. So let's say I call it with 1 argument. How many, what will happen? Does anybody know? One will be undefined and the other will be assigned. If I call it without any arguments, it will be 2 times undefined. If I call it with 10 arguments, what would happen? Yeah, incorrect. So, if there's a change in the method or signature, things might still work somewhat, even though it's not being reported. Then there's a semicolon insertion. What would this return if I call my object? Does anybody know? Wrong. It will return undefined, because I put a new line after return, and JavaScript engine will insert a semicolon, resulting in returning nothing. Okay, conditionals. What is the Boolean value of not empty string? Anybody?
Not a number?
True. That was the answer. But another number would have been nice, yeah. So, if I say not on an object, what would return? It will return false. An object is considered as untrue, so not. So if I compare these two, will it return true or false? True? Correct, because now I'm comparing objects, and an empty string is considered the same as an empty string. However, if we would compare the not of these two, I would get false. Type conversion. Great, great, great. So I've, in the top one, I've assigned a string 1 to j, and then I say plus plus, and then plus is 1. What would be returned from the first? Does anybody know? 3, which it would be logical, yes. Does anybody know what the second will return when I 12, correct. Because in the second, the plus is 1 will actually concatenate the 1 to the string, so it will return 11. And the plus plus is actually an incrementer, which will return 12. 12, yeah. So there's a lot of undefined behavior there. Another pet peeve of mine, actually, is when you have a method like this. It's from Angular material, the create method. It gets a config element. However, if you want to use that library for the first time, which was the case with me, I wanted to know what is config. Well, there's no data type, there's nothing. So if you're out of luck, you're gonna have to dive into the method, see what do they do, what do they expect. And if you're lucky, they provide a whole list of values that the object should have. And basically, it's a type definition in the document. So I'm not a great fan of JavaScript. And also not of any other language that doesn't require strong typing, what that matters. However, it is true that JavaScript is the only scripting language that's supported by all the browsers. So, like it or not, I have to use it if I want to develop for frontend. Yep. So, some people thought, you know, let's create higher level languages and transpile it to JavaScript. So basically, consider JavaScript the assembly of the web and build on top of that so we can avoid making the mistakes, for example, I just mentioned. And they created several higher level language. ECMAScript 6 is actually the follow-up on JavaScript, but currently it's not supported in all the browsers. So it will be transpiled to JavaScript at the moment. Well, you have TypeScript, great with Angular 2, for example. You're shaking now, sorry. Or, oh, sorry. Scala.js, CoffeeScript, Elm. Elm is a little bit more than a language. So, how did I get to Scala.js? I mean, it's not the most common of languages. Initially, I didn't want to use any of those languages, for the simple fact that I would have to learn yet another language. I don't know how the debugging would work with JavaScript and combination of such, and I would think add complexity to my builds. Well, that was 3 years ago. Then a friend of mine and I decided to, in our free time, start a project to create mathematical equations through a website. So server-side, the mathematical equation would be solved, and on the client side, you would be able to enter parameters. Not a very difficult project, you'd think, but we started in 2013. First, I started with JSF, because that was what we were working with at that time. So what I know I use. The server was Java, Glassfish, generate HTML and JavaScript, built to Maven. Well, that's a bit limiting if you want to do more fancy JavaScript. And also JSF has the nasty habit of generating JavaScript. And if that doesn't work in your browser anymore, because Chrome decides, for example, that certain things aren't secure, you can forget about modifying it. Well, then we went to REST services, like anyone should, and basic HTML and plain JavaScript on the front end. Very simple, nothing special. But that has its limitations because you have to build everything. So we decided to use MediaWiki, which is PHP, but it provides a whole authentication framework, templating, everything. It's used for Wikipedia. And we added some JavaScript libraries for it. So we started using Grunt and Gulp and became more and more complex. So eventually we decided, okay, the backend, we might want to use something else. Because I want to use mathematical equations, I want to be able to use DSL, domain-specific language, to enter these. So Scala might be useful. So we changed the backend to Scala. But we kept Maven as a build tool. Then the front end got thrown out. Yeah, we changed a lot. We changed it around so many times I can't even, well, I can't count actually. But the front end was thrown out. We went for AngularJS, which was hot at 2014, which is nice. And we kept gulp and SPT for the backend with play. Then, in 2015, something was brought to my attention. Scala.js became not experimental. It was a milestone, and it was introduced by my friend. And he said, why not use that? So at that point, I was thinking, yeah, why not? Scala backend, Scala frontend. OK, let's use that. And we have one build tool. So basically, the whole build stack became simpler. And at that point, I thought, finally, we're there. So as I said before, I chose Scala for the backend. But why did I pick Scala? Scala provides all paradigms, imperative, object-oriented, and functional. Basically, it's more oriented towards functional, but it does support all. It supports strong typing, statistical typing, type inference, duck typing, all kinds of typing you want. And most important, it supported me in creating a DSL. For example, if you have no arguments in your method, you can leave out the brackets if you want. If you have one argument in your method, you can just use it as an infix operator. So, for example, if your method eats, you could say John eats apples without any addition. And implicit conversion. For those that don't use Scala, that would be like autoboxing, but then customized. So I was able to just write something like this. Add 2 meters to 3 kilometers, and that must be equal to 3,002 meters. Well, I don't need to tell you, if you want to write this line in Java, you'd be, it wouldn't fit in one line. So, Scala.js. It was based on my selection of Scala as the backend. Therefore, I chose Scala.js for the frontend. But where does it come from? It was introduced by Sebastian Dorain at Scala Days 2013. So it's a very young framework. And since 2015, it's no longer experimental. And the most recent version, actually, supports COMMON.js, which is for ECMAScript 2015 compatibility. But it also uses Node.js by default, which I like a little less. And it uses Node.js only for the Google V8 JavaScript engine, if you want to run something standalone. But what does it offer? That's what you come for. It offers Scala in the browser, real Scala, not just something that looks like it. You can access Scala.js from JavaScript and vice versa. Actually, vice versa is even more important. You create easy facades for JavaScript library that already exists, so you can use all the JavaScript ecosystem without too much effort. Can run standalone, although others than testing, there's no real use for it because you have Scala in the backend. And it supports cross-compiling, so you can reuse objects that you want to communicate between front-end and backend. You only have to write them once. So what to expect? Real Scala, macros, implicits, case classes, pattern matching, and all goodies from Scala you can use in Scala.js without problems. There's also a comparison. You can find this on the website of Scala.js between several languages. And it shows that Scala.js really crosses all the marks. It has a strong typing system, although that's a little bit subjective. It has an optimizing compiler. It has extensive standard libraries. There's implicit conversions. It has class with inheritance, modules, everything actually you'd want. However, there are some limitations. One of the biggest limitations is there's no reflection due to on any subtypes of JS. These are the types that you use to match the JavaScript objects. This is actually suggested that you don't use reflections at all in Scala.js. There's also limits enumerations. because those use reflections as well. There's a limitation on the certain JVM exceptions, like null pointer exceptions, because those are thrown by the JVM usually. And since we're not running in the JVM as Scala.js, those are not provided. So there's a different solution for that. And all primitive data types are supported with small caveat. Well, this is an example of a simple oscilloscope running in my presentation. My presentation is actually in Scala.js. It's a reveal.js application. However, oh wait, it is written in a Scala wrapper. So this would be my presentation, and the oscilloscope would look like this. This is basically the Scala.js. Can you read it? Yes? Okay. So basically, these two make it accessible from JavaScript, because if I press a button, it will call this method. And it has several facades for several elements, which are needed from the DOM, which I'll get into later. So what do you need to get started? Basically, all you need is a JDK and SPT. You don't even need Scala installed. The latest version, as I mentioned before, uses Node.js for the Chrome V8 engine, because for the simple fact that it's the fastest. You can use Rhino.js and Nashorn if you want. However, Nashorn has a bug, 64K instruction bug apparently. But Rhino.js was the default, but it was deemed too slow. I hope they fix it somehow, because I don't like installing Node.js on my machine. So you can run the standalone with using JSApp. I will not be demonstrating that, but you can also just access Scala.js from JavaScript. Let's say this is a Scala.js object, just called mySpeaker. It has a method, say my name, I give it the name, and produce a string. To be able to access this from JavaScript, you need to annotate it with JS export. Here I say that is exported as the object SCS speaker, and I would need to export the method. This results in me being able to just call the SGS speaker and just say my name. So I can just call it from JavaScript. But the most important feature of Scala.js are the facades. This so you can reuse existing libraries of JavaScript like Angular, React, and whatever you want. There are a plethora of them. So basically you have 4 categories. Interfaces. You define those as a Scala trait, extend JS any, usually JS object, and you annotate it with JS native. You have classes, JavaScript classes. You define them as a class, too obvious actually, in Scala.js. And again, JS native annotation, and also a JS name annotation, but that's optional, to give it an alternative name in JavaScript. Otherwise, you would have the whole package name in front of it, which would be a bit long. I'll demonstrate it later on. Same for top-level objects. And you can also access global scope variables and functions, like for example the window variable. You can just say, okay, I want all the global variables and methods. All I need is an object which annotates JS native and JS global scope. For example, for facade, let's say I have a facade for the Humpty Dumpty class. So this would be a facade for a JavaScript object. And that JavaScript object should have a value field name, which I define as value name, and I say is JS native for the simple fact that I do not have a filling here. It will be taken care of by JavaScript. It's only a mapping, which I can use in Scala.js. So if I say I have a Scala.js object, so called pusher, which pushes Humpty off the wall, I export those, and that uses basically the Humpty Dumpty object, the facade that I defined above, and accesses its name. So if I would say, let me just get that for a second. If I just say, so this is what happens if you don't define JS name. So if I say push Humpty, I already defined Humpty Dumpty here. Humpty Dumpty was actually this object, Jack. It says a push an egg called Jack, because it accesses this Humpty Dumpty. So if I say David, oh, yeah, I can change the JavaScript object and we'll call that. So, how do you debug? You can easily debug it using source mapping. Scala.js provides simple JavaScript source maps for the Scala object. For example, in the demo I just showed, if I say Humpty Dumpty is, I don't know, this, quote, quote, whatever. No. Oh. Typing with one hand. So an empty object, for example, push, it will tell me it failed, and it should show me. Okay. Well, it would show me normally, but this is a different type of error. Undefined behavior. No. That's nice demo effect. Okay. It does provide source mapping, so I'll show later. There are plenty of JavaScript library facades, however. So you don't need to do all the work by yourself. There's standard DOM facades, there are JQuery facades, Angular facades, reactive facades, you name it. People have started working on it. There's Scala libraries. If you want to do something native or something, you use a Scala library. So there's JDK 8 time implementation. The Scala.z functional library is implemented. UPickle for serialization, deserialization of JSON elements. Scala reactive, etc., etc. And testing frameworks. I believe Scala test is the most popular at the moment, but there are plenty of U-tests, mini-tests, we-tests, etc., etc.
These are all specifically for Scala, yeah?
Actually, U-test I believe is for Scala, yes, but Scala test I believe is supporting Scala as well as Scala, yes.
Version 3.1.
3.1. 3.0, exactly. So there's also nice tooling available. For example, Scala.js Fiddle, which is basically JavaScript Fiddle for Scala.js. So you can also download the Docker images, play with those. You can contribute to it. So for example, if I would do this, oh, I don't have a network available, so I can't really demo that, can I? That's interesting. Oh. But you get the gist. There's dependency management. There's a thing called web jars. Someone had the bright idea of taking all the JavaScript libraries, put them in jars, and publish them through the Maven repositories. So you can just use Maven dependency and download the dependencies without npm or any of those. Or you can use npm. And there's the workbench created by Li Haoyi. He's a guy from Dropbox, also created Oscilloscope as showed earlier. And that allows you to develop a bit more reactive, because it refreshes automatically your front end if you develop and will reload the code if needed. So you don't need to refresh your page each time. It's only for development. So I wanted to show you a little bit about creating a facade, if people would let me. So, yep. Are there any questions so far, by the way? I will ask. Okay. So, in this case, I would like to show you how you would create, for example, a very minimalistic jQuery facade. Who's familiar with jQuery? I may hope everybody. Most of you. Okay, good enough. So let's say I have this application. It's basically a skeleton. It has a build SBT, which is the standard Scala. And all that it has in it is enable plugins, Scala.js plugin, and a JavaScript dependency defined from your web jars called JQuery 311. And below the previous mentioned workbench for a little bit more rapid development. And here in the plugins, I've defined the SBT Scala.js plugin. That's all you need to have to get going with Scala.js. Can everybody read it? Yes, okay. So let's start this, for example. Oh, okay. I'm just going to start. So there are two ways to compile Scala.js. There's fast.js, which I'm using now, which is the fast compiler, fast optimizer. But if you want to go in production, you don't want to use that. You want to use the full optimizer because the Scala.js code, JavaScript code that's generated eventually, will be much, much smaller. But this is much, much quicker. So what it will generate, this build will generate JS dependencies, JavaScript file, which creates the JQuery actually, which I just showed before. It will inject it here. So we can just actually see this jQuery. We have just a project, which is actually Scala.js code converted to JavaScript. And of course, we have my hello world. So, yeah, and then I'll show the page for a second. So basically, it's quite simple, just something to change. And what I want to create a facade for example, is in Scala. In jQuery, I can say, okay, get the class of this thing is change me, and I want to get the text. I get the text, and I can change it. Oh. So it will have changed the text. That's basically what I want to do. So how do we start? First, we start with just creating a class, which doesn't want to open. No. Are you kidding me? All right. Well, I'm going to create a new Scala class then. You don't need any special plugins actually for your IntelliJ. I'm using IntelliJ. It just supports Scala, and that's all you need actually. So, okay, hello to whatever. So let's say I have a class hello, and I say define the method submit is println. Oh yes, hello world, very original. So I can't access it from JavaScript yet. Only if I say JS export, and I say export it as hello, my hello, and then also export the method, otherwise I can't access the method. So it will be automatically reloaded. You can say, okay.
Zijn dat 4 PC's?
Ja, hebben ze genoeg PC's? Okay, sorry about that. So I can just access this by saying my hello. You need to access as a method, the object, and just say submit. That's what I named method, right? Oh, submit. Well, silly me. So this is what the workbench does. Recompiles it in the browser actually. So, and it says hello world. nothing special. So let's start by binding the button I just created. My hello. Submit, because basically that's what you want to do, right? Sorry? Yes, I have to connect it somewhere to my browser. Sorry. Yeah. So I say submit. Oh, because I changed HTML, I do have to reload. Submit. Hello world. Yay. Okay. Now, what we wanted to do was very basic. Oh, now you open, don't you? Yeah. Bye bye. Up. So, no, it keeps existing. So we create a facade. New package object. Not a new package object. I'm just going to create a class JQuery element. Well, no. First I want the globals. Because the dollar method that JQuery provided is defined on global scope. So it's just, I'm going to just use that. So I'm going to say, all right, this is a JS native object. It should match it. Autocomplete, please. Yeah. And I say JS global scope. And what was the method name again? Dollar, right? Dollar. What does it get? A string that is a selector. Yep. And what does it return? I don't know, and I don't care. And what do we? How do you fill it? Just with JS native. This basically tells the compiler, okay, this is just a mapping. So, and this tells it that it's any object from JavaScript object, and this is just a method signature that will match. So now we're going to say hello to. Okay, I'm just going to say I selected no something. So let's see. I'm going to say selection is well, I had the globals, right, and the dollar method. I'm just going to say what was change me was the class. Yes, change me. And I'm going to say okay, no, import. So, and just gonna say okay, print that thing. Yeah. So should not fail. Did I? Submit? No, it hasn't submitted. It failed actually. Let me get back. Why did it fail? Oh. No, I do not have. Refresh. Okay. And it does not do what I want. How about that? Where's the terminal? Here. Okay, recompile. Tell me what went wrong. So, compiling. Compile failed because object globals. It should extend JS object. Sorry. All right. 1, 2, 3. Submit. Okay, what it does says select. Okay, it's an object. Doesn't tell me a whole lot. So I basically want to have the text of the jQuery object. So how do we do that? We create another facade, basically an interface of a jQuery element that we selected. jQuery element, it does not exist. I'm going to create a trait. A new file, trait, extends JS object as I mentioned before, and make it JS native. Okay, so which method do I want from this create element? If I select change me, for example, real official JavaScript jQuery, I can just check the prototype. I see all the methods they have. So the method I wanted was the text method, function value. So we're just going to define the text method. It does return something I don't know and I don't care. And returns JS native. And in the globals, okay, now it returns a JS query element. And I can say text. Okay, provide me. So it really analyzed the text. So I can also make a function for, map the function for changing the text. Oh, no, that's not here in the element. So I say new text here. Oh, great. Yep. New text. String. So for then I just map what it should become. And I'm going to change the text. So, and submit. And it is changed. So, that's how fast actually you can just create a facade. It will just compile to JavaScript and work. The problem at the moment with the fast optimizer, if you would look at the JavaScript created, it would be a little bit on the big side, 223. If you would use the full optimizer, it will become around 150. And it will take a lot longer to optimize.
But it's already minimized?
It is minimized, yes. So I can show you in a second. So here the other one is, well, fast ops. This one, it's 42 kilobytes actually. I thought it would be like 150. So if you want to see it, maybe open it. Nope, plus. Poof. So it would look like this.
This also includes jQuery?
No. jQuery, all your dependencies will be separately packaged in the JS dependencies. So if I open this one, I would see jQuery as is. It doesn't modify, it doesn't minimize it, it just bundles it. So I didn't choose the jQuery minified version. I just said in my dependency jQuery.js. Therefore, that's what I get. And this is the map. So for example, if I go back to my presentation for an example of the mapping, I do have an example. I just realized. Oh, no. Yeah, this one. For example, you want a debug. Let's just select the elements. No, it's not console. It's sources. Yeah, my screen is a little bit on the small side here. Up. Where was it again? Here. So it's in the demo. Oscillo. So the thing that I just showed. This is provided by the source mapping. So if I say put a breakpoint in, it will stop without problems. So, are there any questions so far? The one on the sure on the left side.
You created a mapping for various jQuery functions.
Yeah.
Are there any ready-made mappings available?
As I said before, there are a plethora of libraries that already create. jQuery is one of them. It was just for demo purposes, because yeah.
Also mapping for native client-side libraries.
You mean DOM, like JSON? Yeah, DOM is provided as well.
For every global variable that is stored
Yeah, for the DOM, there is a just basic DOM facade library provided. You can just use it. This is just...
Just better to just write your own and implement just
Usually it's not better to write your own. Just, I would suggest if it's there, use it or improve it. So, for the sake of demoing, I just created everything from scratch. Also in my oscilloscope, I created the DOM elements from scratch. So, just to see how they will be. So, any other questions?
How about the speed? The Scala compiler is not very fast.
Well, we
have a very small file here. If you have
yes.
larger project.
The speed would be about the same speed as a Scala compiler, because it really just uses a Scala compiler, and then some extra for the recompiling direct to JavaScript. It will create a few files if I go to the classes here. Well, this is, yeah, we go to here. You will see two files actually. This is the intermediate class, and this is another file that we'll use for JavaScript mapping. So it will be a bit slower than Scala compiling. But yeah, it's not that strange. If you compile in Scala, that it will be the same. If you write Scala, they will compile at the same speed as Scala. So.
Okay, now I used to do some programming in Scala. Now
Yeah.
I'm using TypeScript, but then it's I'll type in TypeScript, go to the browser F5, and it's there.
Well, during development, however, and the case you just mentioned. So if I type in my developer and the speed to get it to the browser is faster, however, because it uses incremental compiling. So it would be a little bit faster than just compiling from scratch. So it is possible, just as I showed, it is a little project, but it does not go recompile everything. So the deep innards of it I can't explain at the moment, but it does have optimization regarding development. Yes, sir.
How easy is it to use server-side validation and use the same code for client-side validation?
Okay, how is it? It depends. As long as you only use Scala, the basic Scala functionality, not Scala libraries that are written for the JVM and they're written for Scala.js, you can just reuse it using cross-compiling. So there is cross-compiling. Yeah, I use it myself for my project. I use the simple level for the DTOs that need to be communicated to and forth. But you can use more complex items as well, as long as they don't use specific Scala compiled libraries. Or Java, unless there's a mapping for it for Scala.js. So you can get pretty far, just don't count on enumeration, however. I found out the hard way regarding that. Any other questions?
Have you any experience with futures? So if
Yeah. Yeah. And the question would be?
Yeah, well,
sorry, if I have experience with futures, yes. Also with Scala, yes, yeah.
Yeah, but because in JQuery you have that callback help. Can you prevent that in Scala.js? You just use futures for that?
Can you prevent a callback hell in? Yeah, you probably can. I haven't tried it in jQuery anyway, but then you would need to add some extra functionality on the Scala in Scala.js itself. So you have to make a more intelligent framework around jQuery, most likely. Any other questions? None? No? Well, anyway, so that's, you can create a facade within no time, at least a minimal facade. For a proper facade, of course, you want to think some things over, perhaps. And the future of Scala, yes, well, it's only version 06.13 at the moment. So it has quite some time to go. Well, it's only 3 years old, so it's not that strange. And the main developer at the moment was one person. When he presented, it was one person. The community is growing actually quite exponentially, I think. Last year, a lot has changed. And for people who wonder whether or not it will be at any time in the future depend on ASM.js, the answer at the moment would be no, for the simple fact that the memory model that ASM.js uses is not really compatible with how Scala and garbage collection would work. Yeah, well, the question would be, are there any questions? So we had a round already, but still. So you got 5 minutes to ask them, no? Okay, if you want to contribute or participate or have questions, use the Scala.js website. It has extensive documentation about facades and how to get started. There are plenty of skeleton projects or example projects that you can use. And if you have questions, just go to the Gitter. That's for those who don't know. A chat application that was developed by GitHub. Yet another application. But the people there are helpful and friendly, and just if you have a problem, they can answer it. So, yeah, that was my Scala.js, and I hope to see you somewhere in the future in Scala.js environment as well. Thank you.